4.5 billion years ago, Earth was not alive. It was hostile, unstable, and violent. The surface was molten rock. Asteroids struck constantly. Volcanoes tore open the crust, releasing clouds of gas into a sky without oxygen. The sun was dimmer than it is today, but radiation struck the surface unfiltered. There were no plants, no animals, no cells, only chemistry. And yet, within this chaos, the conditions for life were quietly assembling. As millions of years passed, Earth slowly cooled. Water vapor condensed and fell as endless rain, filling basins to form the first oceans. The atmosphere was thick with carbon dioxide, nitrogen, methane, and ammonia. Lightning flashed through the sky. Ultraviolet radiation struck the ocean surface. Deep below, hydrothermal vents released heat and minerals from Earth's interior. These were not signs of life, but they were sources of energy. And energy drives change. In the oceans and shallow pools, simple molecules collided endlessly. Under the right conditions, carbon-based compounds began forming more complex structures. Amino acids assembled. Sugars appeared. Nucleotides, the building blocks of genetic material, formed spontaneously. No organism guided this process. There was no intention, only chemistry following physical laws. Some molecules were more stable than others. Some lasted longer. And those differences mattered. Among the countless chemical reactions, something remarkable began to happen. Certain molecules naturally formed membranes, thin bubbles made of lipids. These bubbles could trap other molecules inside, separating an internal environment from the outside world. These structures were not alive, but they were organized. Inside them, chemical reactions became more concentrated. Changes happened faster. Systems that maintained themselves longer persisted, while others broke apart. This was not biology yet, but it was no longer random chemistry. At some point, molecules capable of storing information appeared. RNA-like molecules could both carry instructions and catalyze reactions. Some could make imperfect copies of themselves. This was a turning point. Copies were not exact. Some versions lasted longer. Some replicated faster. Others failed entirely. For the first time, natural selection began acting, not on organisms, but on molecules. There was no competition for food, no predators, no ecosystems, but there was selection. Chemical systems that were stable survived longer. Systems that could harness energy persisted. Systems that failed disappeared. Over millions of years, these molecular networks grew more complex. Metabolic-like reactions formed, chains of chemistry that released energy and maintained structure. The line between chemistry and life began to blur. Eventually, some protocells crossed a critical threshold. They could maintain an internal environment, use energy from their surroundings, store information, reproduce with variation. These were not animals. They were not plants. They were not even true cells by modern standards. But they were alive. From this moment forward, evolution would accelerate, leading, billions of years later, to complexity, consciousness, and civilizations. But that is another story. This one ends here, at the moment life first learned how to continue.